So the first question I got wrong on this retake was question 1. And the question reads, a student uses a heavy ball attached to a rope as a pendulum in the experiment. The ball is hanging, so the rope is vertical. The student pulls the ball back and releases it from rest as shown. Comparing the measured value to the expected value of the speed of the ball at the lowest point of the swing, the student finds out that the ball is moving slower than expected. Which of the following may account for the slower than expected speed? A, the student did not account for the mass of the rope. B, the ball was accidentally given a small push when it was released. C, the student measured the mass of the ball to be higher than it actually is. D, the student did not account for the stretch of the rope caused by the weight of the ball. And E, the angle of the swing was so high that air resistance had a significant effect. The correct answer was the student did not account for the mass of the rope. Okay, so that was the correct answer. Now, the basic physics principles that apply are U equals mgh, kinetic energy equals 1/2 mv squared, and conservation of energy, and then the mass of the rope, which would be m divided by 2. So the C part is asking to find what could have gone wrong. So if we take the pendulum that is up here, it has potential energy but no kinetic energy. And we have to include the rope of the in the system because it's specifically said to. So that means the potential energy of the system is equal to the 1/2 mv, the final kinetic energy of the system, where mgh, where the mass would be the mass of the pendulum plus the mass of the ball. So this would be mass of the ball, this would be mass of the rope. So when you solve those two together, you end up getting the formula with this. When you plug in m for this, you end up getting V equals square root 2 times gravity times L times 1 minus cosine theta, since the angle is increasing, times the mass of the ball over the mass of the ball plus the mass of the rope. And as seen here, if the student were to forget to include the mass of the rope, if the student were to include the mass of the rope, then this would be a small value. It'll be less than 1. No, that's the wrong side. It'll be less than 1, and that would decrease the overall velocity, causing it to be slower than expected. So for the D part, if the mass of the rope were included, it would decrease the velocity because mass is in the denominator.